Okay, from the previous lessons, you have learned how to approximate the area of a plane region given yung number of rectangles, circumscribed at saka inscribed rectangles. Na kung saan yung circumscribed rectangles, yung sum of that areas is always greater than the area of the plane region, while yung ating inscribed rectangles is always less than the area of the plane region. Okay? And also you learned that the limits of the lower sum and upper sum are equal as n approaches infinity gamit yung right end point or left end point ng ating point of division on the closed interval AB. Okay? Also, you have learned how to find the area of a plane region gamit yung ating limit definition. Ginamit natin doon is C sub I, pwedeng left endpoint yan at saka right endpoint. Okay? Na kung saan yung C sub I, naroon siya sa interval x sub I minus 1, x sub I. Okay? And for this week, pag-aaralan natin yung mga topics na to. No? Definite integral and Riemann sum. And makikita nyo, yung Riemann sum ay na-discuss ko na sa inyo. Hindi ko lang naibigay yung connection ng Riemann sum dun sa ating definite integral. Pag-aaralan natin properties of definite integral, the fundamental theorem of integral calculus, geometric applications of the definite integral, dalawa to, area under a curve, and area between two curves. Okay? Tingnan natin kung matatapos natin to this week. And after the geometric applications of the definite integral, mag-discuss na lang ako ng iba sa inyo or another application of the definite integral. Okay? And ito yung last topic natin for basic calculus. And let's start our lesson dun sa kauna-unahan, definite integral and Riemann sum. We're just going to connect Riemann sum to definite integral. Yung Riemann sum actually na-discuss ko na sa inyo ito. Okay? I-define lang natin at i-connect lang natin sa Riemann sum sa ating definite integral. And here are our lesson objectives. At the end of the lesson, the student is expected to understand the definition of a Riemann sum, evaluate a definite integral using limits, and the last, evaluate a definite integral using properties of definite integrals. So yung third objective natin, sasama ko na lang right after the discussion of the fundamental theorem of integral calculus. Okay? And let's start with the definition of the Riemann sum. If we have a function f and it is defined closed siya sa interval a to b, and let delta be a partition of the interval ab, then ito yung ating mga points of division. Okay? A equal x sub 0, x less than x sub 1, less than x sub 2, until less than x sub n, which is equal to b, okay, na kung saan yung ating delta x sub y, yung width of the ith subinterval from the interval x sub I minus 1, x sub I, wherein yung ating c sub I, any point on the I subinterval, yung sum of the areas of the rectangles is denoted by summation of f sub c sub I times delta x sub I from I equals 1 to n. X sub I minus 1 is less than or equal to C sub I less than or equal to X sub I. Ito yung tinatawag nating Riemann sum of the partition delta. Now, pwede natin gamitin dito yung right end point or left end point. Yung right end point natin, yung interval na tinutukoy natin, yung subinterval na I, subinterval, X sub I si right end point, X sub I minus 1 si left end point. Since yung ating C sub 1 naman lies between X sub I minus 1 to x sub I, pwedeng gamitin yung x sub I at pwedeng gamitin din yung x sub I minus 1 or yung tinatawag nating right endpoint tsaka left endpoint. So ito yung tinatawag nating Riemann sum for the partition delta. At familiar na tayo dito kasi pinag-aralan natin to last week. Okay? Now, what if we have a regular partition from the interval AB? Our definite integral defined as integral of f of x dx from a to b is equal to the limit of the sum of the Riemann sum f of c sub I times delta x from I equals 1 to n as n approaches infinity. That is if we have a regular partition. Pag sinabing regular partition, ay yung ating pong width of the rectangles equal. Okay? And it can be computed using the relation b minus a over n. So, familiar na kayo dyan kasi tinuro ko na sa inyo yan from the previous lessons. And yung ating c sub I dito, right endpoint. Okay? And to solve for c sub I, we have a plus I delta x. So, hindi na natin gagamitin yung I minus 1 times delta x kasi yung left endpoint. Mahirap pa. At mas convenient kung gagamitin natin yung right endpoint, which is I times delta x na lamang. So therefore, c sub I equal to a plus I times delta x. Okay? Again, delta x is width of each of the n subintervals. C sub I any point on I subinterval, pero ang gagamitin daw natin ay right endpoint of each subinterval. Okay? So again, the definite integral can be computed using the relation integral of f of x dx from a to b, or using finding the limit as n approaches infinity of the Riemann sum. No. And for the properties of the definite integral, we have one, the integral of f of x dx from a to b is equal to negative of the integral of f of x dx from b to a. Pag binaliktad natin yung lower and upper limits. That is if a is less than b. We have integral of f of x dx from a to a, of course, equal to 0. Okay? Kasi equal yung lower and upper limits of integration natin. Sorry, that is if a is equal to b. Tanggal na lang ng less than. It should be if a is equal to b. Third, we have integral of f of x dx from a to b is equal to integral of f of x dx from a to c plus integral of f of x dx from c to b. Pwedeng gamitin to if the function f is continuous on the interval ab and a is less than c less than b. Ibig sabihin, nandun siya sa interval a to b, pero yung ating c lies somewhere between a and b. Pwede natin gamitin itong third property of the definite integral. 4, if we have a constant k, pwede natin siyang ilabas from the definite integral. Okay? And if we have a polynomial function or a sum of two functions of our definite integral, that is integral of the sum of f of x and g of x times dx from a to b, pwede nating pagbukurin yung dalawang functions or integrand. Okay? So that is our properties of the definite integral. I'm going to give you an example on how we're going to determine or evaluate definite integral gamit yung Riemann sum. Okay? So therefore, gagamit pa rin tayo ng concept of limits. So, thank you.